I'll go ahead and start the recording. So based on what we covered in the last class, does anyone have any questions or anything they want me to clarify before we start? Okay, I would take that as a no. Probably I did a great job. Kudos to me. Okay, so I would share my screen. Okay, let me just do that one. So we've been talking about OOP, close. Yeah, we've been talking about OOP and classes, objects and classes, right? And I remember we spent a good amount of time talking about, to some extent, inheritance. We talked about the 4 pillars of OOP. Who remembers the 4 pillars of OOP? Anyone? Hello? Can you guys hear me?
Yes, I guess abstraction, right?
Okay.
Um yes, abstraction and encapsulation, right? Something I've really forgotten. But I think calculation, I've forgotten. Serious.
Okay. We talked about inheritance, polymorphism, encapsulation, yeah, and yes, exactly, and abstraction. Okay, so yeah, that shows that at least you guys were paying attention. Who sent in the food this thing? Okay, me, our senior dev. All right, Kosi, welcome. All right, so and yeah, good evening, Kosi. How are you doing?
I'm good, thank you.
Yeah, and then also I have made available the code that we used for the last session. I've made available the code, so you can go to the GitHub and download it, or just see what we talked about. And also the video is up on my page, YouTube channel. I'm not sounding like all these YouTube people. Welcome to my YouTube channel. Okay, so we talked about inheritance, I remember, and I'll just maybe, since we did a bit of coverage on the code on code, I don't know if I should talk about it or we should go to a different topic altogether. And also I think I also talked about abstract classes. If you remember, I also talked about abstract classes. Let's talk about okay, let's talk about interfaces. I know I mentioned it, what it's used for, or why Java introduced it. So let's talk about interface, right? So to do that, let me just create let me create a class, say user, let's just call it user service, right? And it's of type of interface. Okay, so interface I mentioned, it helps us to kind of define methods. Yeah, you can call it an abstract method, and then it includes an abstract methods that we don't have a definition for. We just create them, but there is nobody to it. And the class that is implementing the interface is forced to, depending on how you define the method, the class will be forced to implement or override the method. Remember when we talked about methods, we talked about method overriding, method overloading. So that's one of the things that interface helps us do. So let's say, for example, we are working with, okay, I think it should be better I do interface as package. Oh, interfaces. I can't, because it's a keyword, so I can't use it. Refactor. So on this interface, let's say, for example, we have a user service, right? And that user service is something that helps us to create users, for example. So we have a user class, and the user class has private, just three distinct: name, string of private string, name, email, and yeah, let's just do password. These three things. And of course, we need to have our getter and setter methods. All right. Okay, so let's say, for example, in our user service, we have a method that helps us to create a user. For the purpose of this example, I'll just return a void. That's not the ideal thing. In some cases, that's what you want to do. So it returns it creates user, and then we'll pass our user object that we created. User, we'll pass it here. And say this other one updates a user, so another one deletes a user. If you want to delete, let's find the user by their email. And the last one, say, gets a user given an email. And we want to have this method implemented in a different. So this is like a, will I say, convention. If you're working with Spring Boot, you have your service class, and then have another class that implements your service class or implements your interface. So call it user service import. It's what people call it. Some call it a user service implementation or whatever, but I usually call it user service import. So we have it like this. So it implements user service. So what it's asking us to do is it's forcing us to override the methods that we have defined here. So this is basically how we do this. So override, you can do this one after the other anyways. You can decide to type it out yourself, but that's a lot of work. So there's a way we can, if we have some methods, let's say, what method now can we have here? Let's say we have a method that we don't want to force any class that is implementing this our service. We don't want to force the method to, let's say, which method now? Which method should be? Which method? Okay, let's say, yeah, list all users. A method that lists all users. Enter. And yeah, we can say something like default here. Add body to it. And that way, this guy is still, this guy is still okay with that. So we have to now decide if we want it here or not. We'll decide that. So interface helps us to abstract some of the things that it helps us to define a method, right? Without having to make or write the implementation of those methods. Then the classes that will now use those utilize those methods overrides it and write their implementation. I don't know if you understand what I'm saying.
Yeah.
Okay. And it is a must if any class to implement an interface, it is a must they use the implements, then the name of this implements here, then the name of the interface that they want to implement. Then one of the reasons, if you remember, I mentioned why we use interface, or why Java introduced interface, is because you can't inherit more than one class in Java. If you are using normal inheritance, you can't do more than one. So interface is introduced to combat that. So with this, you can actually implement more than one interface. If we have more than one, we can implement it here and have all the methods that is there and use it to do what we are set out to do. Just to make like a code sample, let me just do a quick definition. This is just an example, but I think something simpler. Let's say we have an interface called, say, Polygon, and we want to get the area of this polygon. So void get area. So we just need the length. Oh, what is this? We need the length and the width of the. So then we have our, say, rectangle, this thing, a class called rectangle that implements polygon. For example, it's forcing us to do this. So just as an example, or just to show that you can actually see, just comma, you can now implement another service, but it will force us to import all the methods or override all the methods that is there. So in this place, basically, we can just do a simple override, say, area of rectangle is, then concatenates the length plus this. Okay, now I'll need to test this one. Just yeah. So I will just have it like this. If we have our main class somewhere here, so just print out this guy. And call our rectangle class. Then rectangle dot get area. Pass any value here. Let's say we pass 9, and we should be able to get okay. Area of the rectangle is this 72. I don't know, is it confusing or is it something that everyone understands the concept? Hello?
For me, I get it actually.
Okay. Does anyone have any question? Now, another thing too, since I don't think anybody has question. So you also need to know an interface can actually inherit inherit another interface. So if we have we have this guy here, it's an interface. We can say extends the one we define user service. This works, but now we have to implement these other guys in here. And that's not what we want because they are two different entities. So if you extend, if this work, if you just the concept of inheritance also applies here. You know, in inheritance, when a child class inherit a superclass is being extended by a child class, right? All the properties that is in the child class can be accessed, that is in the superclass can be accessed through the child class, right? The same concept, but this one interface, because any place because this guy is now implementing it. This guy is implementing Polygon already, so it forces us to all the methods that it's inheriting from the user service, that Polygon is inheriting from user service. It's now forcing us to implement it the same way. So this guy has access to the user service because it says it's inheriting all the it's inheriting it. So all the methods that it has, this guy also has access to it. And anybody that is implementing Polygon will now have to implement or override all the methods that is in Polygon. You understand? Is it confusing or not? Okay, I will take that everybody understands it. Then another thing you also need to know is I know Java doesn't extend more than one class, but when you're working with interface, you can actually extend more than one, right? You can have this Polygon extend this user interface, and then if you have another interface, this thing, it can also extend that one, and it's okay. So those are some of the ways that we can use that. So what are the advantages of using an interface in Java, right? So it provides us with specification that a class which implements it must follow. So if you want to force a class to do some certain things, it provides access to that. So like the example we gave here, when user info, where is it again? When our user info implements this guy, it's forced to override all these guys. And then it helps with abstracting abstracting the methods. Those are the things that it helps us with. Any questions so far?
Okay, yeah, so I have a question. So now,
Right.
I know this, what is it called? This is mostly used, this implementation that is mostly used when someone has authentication, where we have login, sign up, blah, blah, blah. But which other use case is this also being used apart from
It's not just authentication, no. So the way Java ecosystem works, if you are okay, no, I don't think it's just Java, it's a general programming term. You don't want people to have direct access to your business logic. So this guy serves as a way to abstract or add another layer to it. So number one thing you do when we are working with Java, general programming terms anyways, you can, instead of calling this your user object, if it's an entity that is talking to your database, you can add like a DTO, right? you add a DTO. That way, someone that wants to speak to your entity, instead of talking to them direct, because you know that your entity is direct connection to your database, you do all the validation that you want to do. Let me just do this. Let me do this, guy. Java class. Let's say DTO. So your DTO usually have the same. Oh, shoot. Usually have the same implementation as. Usually have the same field attributes as your normal class. So we have private string. I think we have name in the other one. We have add email, and I can't remember the last one. Is it password? I think it's password. I don't know. So if you want to write to your user this thing, so you have to maybe define your user here. You can say, okay, user.set u.set name, instead of having a direct interaction from this place, like your client side having a direct interaction with this, they are passing the information to your DTO. So you do user, which is your DTO now. Oh, okay, I need to do get and setter now. Dot get name. It should be dot get name. I need to do the get and set on this guy. Yes, it's get and setter. Okay. So now, before you even pass these informations, it's advised that you do all your checks. The information is not going to your entity, or it's not being passed to your entity before you make the checks. So interface just helps us add another layer of, will I say, security to our system. It's not I don't think using security is still saying the same thing here, but it's not just when you want to do authentication in terms of security that you want to use interface to. It's just when it helps us to remove direct communication between our database and the clients. So the clients here is your front end. You don't want your front end to just straight up send information to your backend. You want it to be checked and properly vetted before those informations will be sent to your backend. I don't know if you understand what I mean.
Yeah, I guess it. Thank you.
Okay. Any other question? Maybe by the time we start using Spring Boot and all these things would kind of make sense. So I think there's no other questions then. We can go to another. I wanted us to talk about a little bit about polymorphism today. Who remembers the definition I gave? The definition I gave polymorphism. Who remembers? Let's be interacting, no, please. That way I will know that you guys are following. Is anyone on this call? Guys.
I'm not sure how exactly you defined it, but polymorphism is like, or the idea of polymorphism is that it allows different types of objects to be treated as a single type of object. If that makes sense.
It allows what? I didn't hear you.
It allows different object types to be treated as a single object type, if that makes sense.
No, I don't think that's not a good definition for it.
Okay.
Another person. So I said polymorphism allows our, how did I define it? Allows our code to pick, what's it called, a behavior in runtime. So you have something, you have a code, or you want it to act in a certain way when it's doing this. Okay, I used an example of animal, right? So you will have an animal class, and your animal has a make noise, like a method that helps it to make noise or to speak, so to say. But we know that the way a cat speaks is different from the way a dog speaks. So polymorphism is what you would use to say, okay, when I run this thing and it's a dog that is calling this speak class, this is what you should do. It should bark. If it's a cat, it should meow. You know, that's what polymorphism does. On runtime, it gives it a behavior. So let me just give a quick example with code. Close all these guys. I think I should do poly. I don't know if this spelling is correct, but let me show you the example with this code. So our animal class has a method, say make noise, void make noise, right? And it simply prints out some generic noise, or animal makes noise. Now we have a dog, and we also have a cat. Those are two different animals, right, that makes noise. So we now say cat extends animal, and the same thing with dog, it extends animal. So each one has to now override whatever method that is here. So let's do the override here. Void make noise, and say I make cat noise. And same thing, let's just copy here. I make dog noise. Those are two instances here. So in our main class, when we want to run this guy, sorry, let me take this call. Okay, sorry guys. Yeah, so we now say, okay, at this point, we have animal, right? let's say my pets. But when we want to call my pet or instantiate my pet, we say my pet is cat, right? So if we now say my pet dot make noise, we can also do the same thing here. My pet equals new dog. We'll now say my pet dot make noise. So, and when we run this guy here, you see, this is polymorphism in a nutshell. We are calling the same thing, but because we are saying on runtime, this first one, give me the behavior that is in a cat. This is the behavior I am calling here. We are speaking in a sense to the same class, the animal class, but the behavior I want at this first point is the cat behavior. That's why I get the cat noise first. The second one will say the behavior I want is the dog behavior. That's why we got this I make dog noise. Is it confusing or was it explanatory enough? Hello guys, please let's speak. Oh. How many people do we even have? Let me close this guy. How many people do we have here? Come on now. Can we talk? Does it make sense? Is it confusing? So I know if I should throw more light into the explanations. Am I still muted? Is anyone hearing me first of all?
Yes, I can hear you.
Okay.
I
Does it
can
make
hear you.
sense? What I explained, does it make sense? Should I give another example?
Yes, please.
Okay. So what everyday distinction can I use for the explanation now? Okay. This example might be confusing now. Okay. Let's use car. Let's use car. Let me use this guy. Let me put these guys and then move everything into the animal. So I want you outside the factor. To be in the same listing. Okay. So I create another package. Let's say car. So we all know that vehicle is a generic term for cars, right? So and let's say void make a move or something. So S out generic move. Oh yeah. And let me close other tabs. Now, we now have different types of vehicles. We have a truck. we have a car. We have a bike or something, right? Those are different types of vehicle. So when I now want to say, okay, when I call vehicle, I want you to give me different behavior or different moves based on the one I am speaking about. The way your code knows which one you are talking about is, let me go back here and create a new class. The way your code knows which one you are talking about is just by, at the end, let's do vehicle, my vehicle. So if for example, if we are doing this now, we are saying this is not polymorphism behavior. We can't achieve polymorphism because we have defined this guy. We have passed, if you remember, we have passed the constructor. We have created this object and we initialized it and said, okay, the behavior we want is the behavior of vehicle. So if we come here and say my vehicle dot make move, it will give us the move of the vehicle, even though I know I've not extended it in the other guys or implemented the methods. It will say vehicle moves, right? If we come here, do our extends vehicle, copy this. Okay, let me do everything together. Let me override public void. What did I call it again? A vehicle move. Like a truck. Then car. Extends vehicle. This extends. Oh, not car. Vehicle, I beg. Vehicle. So let's say, for example, we have all the methods, the override method here, because, and this one moves like a bike, moves like a car, and moves like a truck. We'll have all these things here. But since we are not pointing to any of them, we're not saying on runtime, give me the behavior of a truck, on runtime, give me the behavior of a car. If we call this guy, it just runs and gives us this guy, gives us the behavior that is in the vehicle. But if we don't define it here, number one, of course, it will throw an error because we've not defined this guy, so it won't even be able to call the one that is inside. So, but now we're not saying, okay, my vehicle is of a type of bike. So even though we are still pointing to vehicle in this our object, the behavior we are referencing is from bike. I don't know if it makes sense. Remember, I think we'll have to maybe revisit constructor if it's confusing. We might have to look at the constructor again in our next class. What do you guys think? I think we should look at constructor again in our next class, because that's where the whole magic. This thing is what makes the whole thing. That's what makes the whole runtime polymorphism what it is. This guy here, if it's whatever thing you are pointing to at this point, is what it will give you the behavior. So in the next class, we'll just go back and talk about constructor again. So at this point, remember initially it gave us the vehicle move, but if we run it again now, it would give us anything that has to do with bike, the behavior that has to do with bike. Sorry, 1 second. I need to attend to something from work, guys, please. I'm here now. Sorry, I don't know. Let me stop sharing my screen. A moment, please. And then do this. It's not opening on my phone. Oh, sorry. Okay, I am back. Well, guys, I don't know. Are you guys understanding my explanations, Biko?
Yeah, I get it.
Okay. And we would have to visit, we'll have to talk about constructor again, because I guess maybe that's where the confusion is. Or we just have to talk about it again in the next class, maybe tomorrow. Not my class tomorrow, I don't know, but I'll let you guys know. So, but in our next class, we'll talk about constructor again. So, but I would share, I don't know, I shared already, not that I would share, I shared some materials with you guys. It's always good if we are talking about a topic, you probably must have read about it. And so you have a question that you would ask, because coming here and I am asking if you understand it, nobody's responding. And then I know that, or I feel like it's confusing and I don't know how to direct my teaching to help, or based on the questions that you're asking, to assess the level of your understanding. It's not an easy task. It's not an easy task on my own side. So I would share the materials again. Hopefully you guys would pick it up. And I think I'll just look for the page that talks about constructor and share specifically. So you read up on it and understand what we are discussing. So you'll be able to follow along in the next class. So I don't know if anybody has any questions for me based on what we taught today or in the last class or anything.
No, I don't have any. For me, I don't have any questions.
Okay. Lazarus, Bemi, Kosi, any questions?
No question
So
from
I
me.
don't really have any question.
Okay. Lazarus, it sounds like you're confused.
Yes, so after
Okay.
the class,
No, you can actually ask your question here.
not
Ask your
question. No.
question.
My problem is to install this thing so that I can be practicing all the videos that you have been
Okay.
sending to us.
Did you reach out to Bemi? Let me stop recording. Did you reach out to Bemi to help with that?